Okay, our next paper, which is the last one for this before coffee break, is a pivot to autonomous function applications in the marine and offshore industry. It's presented by Chih Wei, if I say it correct, who's a senior managing principal engineer at American Bureau of Shipping, ABS. Chih Wei, over to you.
Yep, thank you, Chair. So a very good morning to you all, and it's very pleasant to be able to see you all here in person today after such a long while. Okay. So 2021 has been an eventful year for autonomous developments in the maritime industry. Much progress has been made on all fronts. Ongoing projects trialing autonomous technology globally, including those here in Singapore, have progressed, and new projects have been announced. So in a step forward, the IMO has also concluded the Maritime Autonomous Surface Ships Regulatory Scoping Exercise. Well, the discourse on maritime autonomy has tended sometimes to view autonomous vessels in a uniform manner. However, this viewpoint is not suitable. The technological and regulatory changes vary depending on the vessel type, its size, and operating profile. So Maritime UK has proposed classifying MASS into 5 categories as shown. They range from ultralight to large and high-speed vessels. So my presentation today will focus on large vessels. Today I will provide updates from the IMO MASS regulatory scoping exercise, discuss on the degrees of autonomy proposed by some organizations, and put forward the notion that current discussions for maritime autonomy should focus on functions instead of a fully autonomous vessel. Okay. So the IMO embarked on a regulatory scoping exercise for MASS in 2018. Through this exercise, various IMO instruments such as SOLAS, MAPL, COLREC, etc., were examined for its impact on autonomous operations. That is, does it obstruct or disallow autonomous operations? And what are the necessary steps required in order to facilitate the development of autonomous regulations and operations in the future? So upon conclusion of this scoping exercise in May 2021, which was delayed by a year due to the pandemic, the IMO has identified potential gaps and themes which need to be resolved and overcome in the efforts to develop regulations for autonomy. The major gaps and themes are the meaning of the terms master, crew, or responsible person. Clear definitions are required for these key roles. Secondly, remote control station and center. This is a new concept for IMO, where certain portions of vessel operations and command are carried out remotely from the vessel. This concept needs to be clearly elucidated, and it has a major impact on the wide spectrum of maritime operations. And connected to the previous point, remote operator as seafarer. How do we classify remote operators in the maritime ecosystem? What special skill set or knowledge does he or she ought to possess? And do they need to be experienced and certified mariners? And lastly, terminology. So IMO does not have a consolidated list of terminology. It is normally embedded in the various instruments. So in order to carry out, to develop autonomous regulations, an agreed upon and consolidated list is required. So upon conclusion of the scoping exercise, the next steps are to discuss and produce regulations governing autonomous operations. Currently, the IMO is leaning towards producing a consolidated MASS code, and they have set an ambitious target of 2025 to produce this code. In the next MSC 105 meeting later this month, a roadmap for this effort will be developed. So in the next 2 slides, I will discuss on the degrees of autonomy proposed by some organizations. So autonomous developments in the automotive industry is ahead of the maritime industry. As such, in the early days, we referred to the levels proposed in the document SE J3016. This standard prescribes different levels depending on the responsibility split between actions and by humans and by system. Well, while this document is a good start for discussions, its scope is limited to one function, which is driving. So it is not easily translatable to the maritime world, as operations in maritime is multi-dimensional, and we have multiple functions on a vessel. Next, for the purpose of the mass regulatory scoping exercise, the IMO crafted 4 degrees of autonomy as shown here. These levels created some confusion. For degree 1, don't we already have ships with automated process and some form of decision support? These aren't really autonomous vessels per se, but just highly automated vessels. For degrees 2 and 3, as discussed, remote control is a new topic altogether in IMO instruments. So while it is acknowledged that discussions on autonomy and remote control will come hand in hand, the technical and technological considerations for these 2 areas are different. Remote control technologies do not have some form of determination, self-determination, which is the core principle of autonomy. So during the course of the scoping exercise, doubts and questions were raised by various flag states about these levels. A commonly accepted set of degrees of autonomy for vessels will have to be discussed and agreed upon at the IMO. Okay. So Ringbaum and Collin recognized the technological confusion in the discussions of maritime autonomy, and bringing us back to the basics, they broke down ship automation into 3 elements, which are technical capability, manning, and autonomy. Technical capability refers to the capacity of the ship systems to perform the tasks required of it, especially in terms of remote operability and intelligence systems. Manning refers to the availability of competent operators, whether they be on board the vessel or away from the vessel. And finally, autonomy refers to the division of tasks and responsibilities between humans and systems. So these 3 foundational elements are important, and they should inform and guide the industry as we develop autonomy levels and regulations. So on the class societies front, various class societies have published their guides or advisory documents. They are generally based on the concept of a fully autonomous vessel and reflect the principles from Ringbaum and Collin in different formats and arrangement. So as such, in maritime, the definition and degrees of autonomy are still a work in progress. As we have seen, various organizations have put forth various levels of autonomy. So currently, there is still no clear and commonly accepted definition. So moving forward, we put forward the notion that we should actually be focusing on functions instead of a fully autonomous vessel. So in the early stages, the industry understood autonomous vessel as a ship that performs all tasks during a voyage autonomously. And more often than not, they are unmanned. As development progressed, the industry came round to the idea that autonomous operations do not equate to unmanned operations. And now in the 3rd stage, we are seeing a shift to focusing on functions instead. So why functions? Well, alongside the discussions of autonomy, we have to recognize that there are major changes taking place in shipping today. Decarbonization and digitalization will bring about a paradigm change to the design and operations of vessels. Firstly, a transition in energy source is taking place. The adoption of alternative fuels will necessitate major changes to the design of ships. The incorporation of multiple energy sources and energy storage systems on board will result in a new electrical power generation and distribution design. Current regulations, which revolve heavily around the diesel engine-centric design will change in the future. Secondly, data. Sensors are collecting data on all aspects of vessel operations. Smart and digital tools leverage upon this data, and insights will flow freely between different onboard systems in order to optimize operations. So the various systems on board will eventually become more integrated into a system of systems architecture. And finally, vessel operations will be more integrated with shore operations. Digitally connected tools will enable data collection, analysis, and real-time delivery of information between seafarers and the shore operations. So onboard controls and information will no longer exist in silos. So these changes will result in the move from a prescriptive to a more functional and goal-based regulatory regime. Rules will no longer be equipment or system-based, and our view is that an autonomous vessel is really just a vessel consisting of various autonomous functions. So we define a function as follows. Taking from STCW, we define it as a group of tasks, duties, and responsibilities necessary for ship operation, safety of life at sea, or protection of the marine environment. And an autonomous function is defined as a function where systems perform all 4 stages in the operational decision loop, which is monitoring, analysis, decision, and action. So, focusing on functions, in our opinion, is a logical intermediate step towards the development of a fully autonomous vessel. With this step, it will be slightly easier to allow such functions to be used within the existing regulatory framework, and therefore shortens the time for implementation of such functions today. So with increasing use of these functions, it will allow the industry to gain experience, improve and further develop the technologies, and to increase industry's confidence in adoption of autonomous technologies. Furthermore, a focus on functions will allow the developed regulations to apply to both ships and the offshore industry. So in conclusion, we opine that developments of autonomous technology and regulations should focus on functions at this point instead of a fully autonomous vessel. This is a more practical approach, and this approach allows the technology to be easily adapted and used within the current regulatory framework, and a shortened time to implementation will hasten its use and allow the industry to gain valuable experience, improve technology, and increase confidence. Finally, we need to keep an eye on the important work ongoing at the IMO. So the MSC meetings in the coming years will be critical in the development of autonomous regulations. So in fact, the idea for function-based regulations has already been proposed by Norway and will be discussed at the MSC meeting later this month. So, thank you.
Thank you, Chih Wei. Okay, we have time for questions. Here's one. Please state your name, your organization.
Rick Parker, A-Star in Singapore. Thank you, excellent presentation, and I think very thought-provoking. The move from absolute to functional regulation is something the other industry I'm familiar with, aerospace, has already gone down that journey to a great extent, and it allows you to make changes more rapidly and more quickly because you just have to assess that the change achieves the functional goal, not that, you know, you don't have to go back and put that particular instrument or something into the regulations. But it strikes me one of the difficulties we're going to have is that as AI gets used more in autonomous systems, they become less deterministic. So you cannot, with certainty, always predict that a given set of circumstances will lead to a given functional result. So I value your view, but it strikes me you have to think of certifying the system more like testing the captain. So you have to make the system sit an exam just like a captain would before you let him loose on the ship. Do you agree with that approach?
Yes, we agree. I mean, traditionally in maritime and from a class society point of view, we have always looked at the hull, machinery, electrical piping systems. Of course, computer-based systems are not new, they've come in, but the current view is kind of a look at the software engineering point, but we agree with you, and a lot of work is ongoing. We need to look at systems which perform AI, machine learning, and utilize data. And going forward, from a class point of view, what we think is that modeling and simulation will become more important as we go forward. We need to create models of the system in a computer environment, simulate. So let's say autonomous navigation and AI. We need to know that the AI supporting this technology is robust enough that it will do what it's designed to do, and it will not. It can handle failure, and if a failure occurs, and that's where the concept of operations come in. I think some of the earlier presenters have mentioned too that from a class point of view, we need to know when it fails, how does the system fail? Will it fail safely? So we agree with you, and we are also extending to AI data and in a sense the cyber physical part of the certification. Thank you.
Okay, more questions? I think it was a very good presentation. It clarified the approach and the topics that we need to address, and so I thanks for that.
Thank you.
Okay, thank you.